Hi, sixth graders. We are starting our rates and ratios unit, which is unit 5. So at the beginning of a new spot in your notebook, label unit 5, rates and ratios unit, and then this lesson is on ratios. Our learning target is being able to write ratios in simplest form and determine whether two ratios are equivalent. So when we look at these three pictures, we ask ourselves, what do they all have in common? Well, this one right here, we have 3 diamonds and 5 hearts. So we would say 3 diamonds to 5 hearts. So 3 to 5. Here we have 3 red tiles to 4 blue tiles. So we would say 3 to 4. So 3 red to 4 blue. And then here we have 5 girls to 15 boys. So we would write it as 5 to 15. These are all examples of ratios. So if we look at this diamonds to hearts once again, I could write it 3 diamonds to 5 hearts. I could write 3 diamonds to 5 hearts, or 3 diamonds to 5 hearts. So you want to know how to write ratios all 3 different ways. So if you want to take one of these examples and write it these 3 ways. We say it the same. I would say 3 to 5 for all of these, but we can write it differently. And the definition of a ratio, which you will want to write down in your notebook, is a comparison of 2 quantities by division. So we can see, again, all 3 of these examples, we have 2 different quantities. So girls and boys, tiles, red tiles and blue tiles, and then diamonds and hearts. And we are comparing them by division. And then here's another example of how we would write it. 3 to 4, 3 to 4, or 3 to 4, or 3/4 is as a fraction. This is how if we use the variables and express it in algebra. To set up a ratio, you need to know what numbers are being compared. We need to write the numbers that are being compared as a fraction, because that's the easiest way to put it in simplest form. The first item is the numerator, the second item is the denominator, and then we write it in simplest form. So let's set these up together. You don't really need to write this down unless if you want to. Janine has a bag with 3 bouncy balls, 4 marbles, 7 books, and 1 orange. Number 1 says, what is the ratio of books to marbles? So I look at books, and I can see books has 7. So there's 7 books in the bag. To marbles, marbles has 4. So that's one way I can write it. Remember, I can write it with a colon, 7 to 4, 7 to 4, or 7 over 4. Okay, so this means, again, this means there's 7 books to 4 marbles. So for every 7 books, there's 4 marbles, is basically what the ratio is saying. So if I look at it as a fraction, and then I need to put it in simplest form, so I ask myself, is there a number that both 7 and 4 can be divided by? Which there is not. So then in simplest form is just going to be 7/4. The ratio of bouncy balls to marbles. So we have 3 bouncy balls to 4 marbles. I write it as a fraction, 3/4, and we know that that is in simplest form. What is the ratio of bouncy balls to the total number of items in the bag? So there's 3 bouncy balls, and then we add everything in the bag. So 3 plus 4 is 7, plus 7 is 14, plus 1 is 15. I'm going to write this as a fraction, so I'm going to go up here so I have more room. 3 to 15. So this says that 3 items in the bag are bouncy balls, and there's 15 items in the bag. So for every 15 items in a bag, 3 will be bouncy balls, according to what Janine has going on with her bag right now. So then we can write it in simplest form, and I know that 3 and 15 can both be divided by 3. So then it would be 1/5. And then we would say 1 to 5. So for every one bouncy ball, there's 5 items in the bag. That is how we would talk about and express ratios. Field trip. So use the information in the table to write each ratio as a fraction in simplest form. So if you feel comfortable and you want to pause me and try to do all 4 of these in your notebook, that would be great. I would suggest writing this whole table down, whether you're going to do this with me or on your own. Write the table down, and then you can have these 4 examples. So you have good examples of ratios in your notebook. So we have adults to students. I can see there's 24 adults and 180 students. We have to write it as a fraction in simplest form. I know that 24 and 180 can both be divided by 2, so we could start that route. I know they can also be divided by 12, so I'm going to divide them both by 12. And I get 2/15. So this says that for every 2 adults, there are 15 students on the field trip. Students to buses, so there's 180 students. There's 4 buses. I know they can both be divided by 4. 180 divided by 4 is 45. 4 divided by 4 is 1. Now, we just finished the fractions units, and we were told that if we end with a fraction in 1, that it's just going to be that whole number alone. But with ratios, we keep the 1. It's really, really important to have a number on the numerator and the denominator, because this tells us that for every 45 students, there's 1 bus. If it was just 45 alone, this really doesn't express anything. Does it mean 45 buses? Does it mean 45 students? Does it mean 45 total people? So we have to keep the 1 because now we know that there's 45 students on a bus. Buses to people, so there's 4 buses, and then there's 180 students and 24 adults, so we add those together and we get 204. We know that they can both be divided by 4. 4 divided by 4 is 1. 204 divided by 4 is 51. Again, we keep the 1, which we would anyways in a normal fraction, but now this tells us that there's 1 bus to 51 people. So notice that if we look up here again, the 45 is for students because students comes first. The 1 is for buses because buses come second in this ratio. Notice that buses is first here, so the 1 goes with the buses, the people goes with the 51. So this tells us that on 1 bus there's 51 people, which we know 45 are students. We just found that out. So that means 6 adults are on each bus. And then adults to people, there's 24 adults, there's 204 people. We can divide those both by 12, and we get 2/17. So there's 2 adults for every 17 people. So if there's 17 people, then there would be 2 adults. And then if we want to check to see if ratios are equivalent, this is a word you need to write down with the definition. Equivalent ratios are ratios that have the same value, which makes sense because the equivalent has equal, part of the word equal in it, which is same value. So determine whether the 2 ratios are equivalent. So 200 miles in 4 hours and 500 miles in 8 hours, or 250. I think I just said 200. 250 miles over 4 hours. Remember, the number that comes first is the numerator, and the number that comes second is the denominator. If by chance you're given a ratio and maybe it said 250 miles in 4 hours and then 8 hours for every 500 miles or something like that, when you're comparing ratios, you do need to make sure that you have the same units or the same quantities for the numerator and the denominator. So notice that on the top I have the miles and on the bottom I have the hours. So now we need to check to make sure and see if they're equivalent. So we could do this a couple different ways. We can do, we can see, so we can change them into the same denominator. I can see that 4 can go into 8. So if I just do 4 times 2 and 250 times 2, I would rewrite this. So let's see, let me erase these. I could rewrite this as 500 over 8. And then I can see that these are the same. So yes, they are equivalent. That means that if someone drives 250 miles in 4 hours and then someone else drives 500 miles in 8 hours, that they are going at the same rate or the same speed. If we have 8 cups of flour to 8 cups sugar and then 2 cups flour to 8 cups sugar, 8 cups flour to 14 cups sugar, I'm going to write 2 cups flour, we'll just write it like that, over 8 cups sugar. For now, we're going to write an equal sign just until we check to see. And then 8 cups flour over 14 cups sugar. So I can see that 8 cannot go into 14 evenly, but, and that's really what we need to do to figure out if they're equivalent or not. But I can see that 2 can be multiplied times 4 to get 8. So if I do times 4 here, and remember if I do something to the top, I have to do it to the bottom. So if I rewrite this as 8 over 32, I can see that 8 cups flour in this recipe, I would need 32 cups of sugar. Yikes, that's a lot of sugar. I bet they're really, really good. And 8 cups flour here would only need 14 cups sugar, so that they don't have the same rate. They're not the same, so then that means they are not equivalent. Okay, and then Derek Jeter had 32 hits out of 93 times at bat. Jorge Posada had 11 hits out of 31 times at bat. Are these ratios equivalent? So 32 over 93, and then we have 11 over 31. I can see that 31 times 3 is going to equal 93. So then I can do the same here. So I'm going to rewrite both of these ratios. 33, 93, and I can already see that they're not equivalent. So no. I want to do one more quick example. So let's say I have 2/3 or something like a ratio of 2 boys to 3 girls, and then here we have 3 boys to 4 girls, and we want to know if they're equivalent, which I know you're probably thinking you already know that they're not, but 3 cannot go into 4 and 4 cannot go into 3. So this way, if we have something like this, we would need to find a common denominator. So then I know 3 and 4 can both go into 12, so I would change this to 12ths. I would change this to 12ths, and now I can rewrite it as 8/12 and 9/12, and then I would be able to tell that they are not equivalent. So sometimes you can just, like here, you can just change the one of the denominators or one of the fractions to get an equivalent, and other times you might need to change both like we had to do here. All right, that is all I have for ratios. So make sure you have your notes for class tomorrow, and have a good night.